so our warm-up here leads us to exactly what we're going to be working on. Given our first method with the black, we could do the problem a to the 6th divided by a to the 10, and it gives us this answer of 1 over a to the 4th. But when we use our other method from Friday in the blue, 6 subtract 10 gives us negative 4, and so we wind up getting an answer of a to the negative 4 with one method, 1 over a to the 4 using a different method. And our focus today is actually to say that's the same thing. In particular, the stuff that I circled here in the red, it's the same answer, just written two different ways. We are actually going to see then how to work with these negative exponents, because with our previous work, we did these pieces with adding exponents, we did the pieces with subtracting exponents, but we never did anything with negatives. Today, that's what we'll do. We'll review those same pieces from our previous video, our previous lesson, but now we're going to start putting some negatives involved with it too. Also, we have this a to the 0. It's going to be the same thing as a 1. We will also start reviewing a 0 exponent. And in fact, that's exactly what we're doing today. Our focus is to just see how to work with negative and 0 exponents. How do you rewrite them? How do you work with them? And basically, it's the same stuff that we did before. It's just that we'll be using negative numbers instead of positive numbers. Now, the two important facts to remember, the two things that we're going to use just everywhere here. If you can take any base, as long as it's not 0, and you take it to the 0 power, it's 1. And it doesn't matter what it is. We could take 5 to the 0, and that's 1. You could take negative 3 to the 0, and it's 1. You can have even really crazy stuff to the 0 power, and as long as that stuff isn't 0, it's 1. Really, really straightforward. Anything to the 0 power will equal 1. You just have to remember that particular rule. Furthermore, it doesn't matter what it is, as long as it's not 0. Anything, any base except 0, we could take with a negative exponent, and we can change it from a negative exponent into a positive simply by dragging it down to the denominator. When we drag it down, we'll leave 1 behind it at the top. And so we could take something like 10 to the negative 2. Bring it down, and it would be 1 over 10 to the positive 2. To start off with then, how would you rewrite 4 to the negative 3 so that we have only positive exponents? 1 over 4 to the 3. We're done. That's it. Going to question B. Notice how we have n to the 0. Well, what is n to the 0 power?
1.
That's 1. So that's our definition of a 0 exponent. Anything to the 0 equals 1. Now we would have m to the negative 5. That would be 1 over, and negative 5 gets switched to positive 5. We're done. Progressing to part C. What we're observing then, any negative exponent can be switched to positive as long as you change its spot. If something already has a positive exponent, just leave it alone. In this instance, what is the exponent on 13? Positive 1, so as a positive exponent, we'll leave it in the numerator. What is the exponent on the x? positive 1, so as a positive, we'll leave it in the numerator. What about the exponent on the y? That's a negative. As a negative, that's one that we'll take to the bottom and make it positive. And we're done. Everything now has a positive exponent. I'm getting a little bit of practice in. What is 33,333 to the 0 power? 1. 1. Anything to the 0 power is 1. What about 7 to the negative 3?
1, that's bar thing, and
Over.
1 over 7 to the third.
yes.
We're done. What about 2z to the negative 2? Of course, we have to pay attention to the exponents. 2 already has a positive exponent. It's going to stay in the numerator. But the z portion, since it's a negative exponent, that's got to come down. And so we have z squared in the denominator. We're done.
X.
For question number 4,
Second number.
the 3
X.
will stay in the numerator because it has a positive exponent. Since x has a negative exponent, that'll get dragged downward.
Y.
And y has a positive exponent,
So
so
it's up.
it stays up. We're done. The focus of this particular assignment is just learning how you can rewrite these things, how you can manipulate them and move them. So what about here? 1 over 15. Well, now we don't want fractions involved. Basically, this is just working backwards. If we want to get rid of them, well, this is 15 to the positive 1. So to get rid of the 1 over fraction, we've got to switch it from positive to negative.
Oh.
Essentially, this is just showing us then that if we want to move something from the bottom up to the top, if we're going to move something from the denominator up to the numerator, all we have to do is switch the sign on the exponent. Switch it from positive back to negative. So for problem B here, well, a cubed is already in the numerator. We don't need to do anything with that. But to get rid of the denominator, c to the 5th, we've got to switch it to a negative. And we're done. We've eliminated the fraction bar as the directions asked us to do, just by switching it from a positive exponent up to a negative exponent. All right, so let's continue. 1 over 18. Right?
18 negative 1.
18 to the negative 1, which is true. However, I want to stop right here and show you something else. One part that you should recognize, 18 is 9 times 2, and of course 9 is 3 times 3. So just by creating the prime factorization, we know 18 is 3 times 3 times 2. That is, it's 3 squared times 2. With this exponent, another way that we can write this out. Writing down 18 to the negative 1 is correct. There's nothing mathematically wrong with writing that out. However, when we get our factored form like this, we could actually rewrite this then. Instead of being 1 over 18, we know that it's 1 over 3 squared times 2 to the first. This is a piece that could be rewritten then as 3 to the negative 2 times 2 to the negative 1. We could bring up both the 3 and the 2 by switching those exponents from positive to negative. For this particular problem, I don't expect you to write it out this way. All the stuff that we had here with the prime factorization, I don't expect you to do it for this particular one. But there is an issue showing up here with number 6. In particular, if you wind up taking this answer and simply saying it's 100 to the negative 1 power, that's not going to be good enough. One of the things that you should observe, 100, because it has 2 zeros, we could actually write that as 10 times 10. So because it has 2 zeros, it's actually 10 squared. This is a problem that you should recognize as 1 over 10 squared. And then when you rewrite it, this should be 10 to the negative 2. Now, in the blue there, 100 to the negative 1 power, mathematically that is correct. It's not wrong to say that. But it's also not exactly right either, because it's not simplified. It's similar in idea to if you start giving an answer as a fraction and you say 50 over 100, you can have a correct answer of 50 over 100, but 50 over 100 should be simplified to 5 over 10. 5 over 10 should be simplified down to a half. Writing your answer like this in the blue, although mathematically correct, is not simplified, and so it's still not what we want to see. For problems like this, especially for something simple and direct, like 10 to the negative 2 or negative 3, 10 to the negative 4 power, it should be written out this way instead of just having a negative 1 exponent. Continuing now to question number 7. And we'll clear this up just to create some space. How would we have to rewrite this without a fraction? 3 is already in the numerator. We don't need to do anything with that. But to change it from c squared in the denominator, move it up to the numerator. Positive 2 has to get switched to negative 2. And we're done. For x to the 5th over y to the 7th, y to the 7th needs to get moved up. So we'll switch it from a positive 7 to a negative 7, and there we're done. Lastly, we need to take our work today with negative exponents and combine it with our previous work on multiplying and dividing powers. In particular, we've already seen that when you multiply powers, what do you do with the exponents? Just add them. So when we're multiplying the bases, we just have to add the exponents. What is 12 plus negative 4? Positive 8. We're done. On Friday, we were doing these same things before. It's just we didn't have negative numbers to add. Now we will. Similarly, on Friday, we saw division has the shortcut of subtraction of exponents. N to the negative 4 over n would be negative 4 subtract 1. And with our previous work, we didn't have to worry about adding or subtracting these negatives. Now we will. What is negative 4 subtract 1? Well, just following our rule for same, change, opposite. Adding the opposite, negative 4 plus negative 1, that's negative 5. And thus we're done. We have, I'm looking at the directions right now, and I didn't catch them right away. The directions tell us to write the answer with positive exponents only. And our answer at this stage is correct, but because it has a negative exponent, it doesn't fit what the directions tell us to do. Well, we're going to have to rewrite it then. What do you do to change it from a negative exponent to a positive exponent? Just move it to the bottom. And there we're done. When you actually write these pieces out with your homework, you'll wind up taking something just like this. 6 to the 12th times 6 to the negative 4. That's 6 to the negative 12 plus negative 12, that's a positive 12. 6 to the 12 plus a negative 4, that's 6 to the 8. And we're done. For this b, you could write it up as 0.7 n to the negative 4 subtract 1, which is 0.7 n to the negative 5, which is 0.7 over n to the 5th. Your practice in class and your practice with the homework should look like that, showing all the steps, not just an answer at the end. All right, so 0.3 to the 10th times 0.3 to the negative 7th. We know that when you multiply bases, the base will stay the same, but then do the exponents. We have to add, so 10 plus negative 7, positive 3. And since we already have a positive exponent, we're done. For question number 10, the 7 is already in the numerator. We'll leave that alone. But then we have d to the negative 4 divided by d squared. We know that we have to subtract then. So negative 4 subtract 2. Negative 4 subtract 2 would equal negative 6. But since we have to have a positive exponent, we could then take that back down to the denominator, switch it from a negative 6 to a positive 6, and we're done. That's all we needed to do for this lesson. We're just looking at how do you work with negative exponents. We just need to keep in mind that if you switch its location, moving it down to the bottom, you'll change the sign. If you move it back up to the top, you'll change the sign back. Whether you move the power up or down, just change the sign. We've seen that we have the product of powers property, the quotient of powers property, and it's the same stuff that we did before. It's just we have to add and subtract integers instead of adding and subtracting whole numbers like we did before. Lastly, anything to the 0 power is 1. The only exception to that is 0 to the 0, which we aren't going to mess with.